as I look at my learning target here for empirical formula, it is to determine the empirical and molecular formula from the percent composition of a compound. So obviously today we are dealing with empirical formula. We will deal with molecular formula tomorrow. Okay, so that's my learning target. My success criteria is to be able to determine the empirical and molecular formula from the mass percent. We're going to work a couple examples, and then you're going to work one on your own. So go ahead to start off with, copy this question into your notes, and then we will work it. If you don't have your periodic tables handy, go ahead and take those out. We're going to need those to do the empirical formula. Excuse me. The question says, find the empirical formula of a compound that has a percent composition of 74.17% mercury and 25.83% chlorine. Now, we dealt with percent composition immediately preceding empirical formula. Did a couple, or at least did one lab on it. So as I look at that, 74.17% mercury, what I am going to do is I'm going to change that percent. Instead of have percent as so, I'm going to switch that and just say, okay, I have grams. So basically what I'm doing is I'm saying I have 100 grams of the particular compound. Because what is a percentage actually? It's out of 100, isn't it? Okay. So I'm going to say I have 74.17 grams of mercury, and then I'm going to have 25.83 grams of chlorine. Now, why did I put that into grams? Because I'm going to flux capacitor from grams to moles. How do I do that? I need to have the molar mass. So I'm converting this to moles. Well, I know that mercury has a molar mass of 200.59 grams of mercury is 1 mole of mercury. Where did I get that value? That came straight off of the periodic table. Okay, that's the atomic weight on the periodic table. So when I do that and do my math, I'm going to take 74.17 divided by 200.59, and I'm going to come up with a value of 0.3698 moles of mercury. So all I've done is figured out how many moles 74.17 grams of mercury would be. Got to cancel there. I've converted that into moles. I'm going to do the same thing with my chlorine here. So I'm going to set up my conversion bracket. I know that 1 mole of chlorine has a mass of 35.45 grams of chlorine. My grams will cancel. So if I take 25.83 and I divide it by 35.45, I get a value of 0.7286 grams of chlorine. So basically all I've done is I've taken a percentage, pretend I had 100 grams of it, and then I converted those into moles. Yeah. Oh, I'm sorry. Yes. It would not be grams of chlorine here. My bad. Mole of chlorine. Okay. Now, nothing's new. We haven't done anything new yet because we've done, mass to moles. We've done percent composition. The new part is, though, in order to determine the empirical formula, I am going to compare my moles of each of the individual elements. So I look, which value has the lower amount of moles? Well, obviously, 0.3698 is smaller than 0.7286, isn't it? So what I'm going to do is I'm going to divide both of these by 0.3698. Obviously, when I do this, that is going to give me 1, isn't it? Anything divided by itself is going to give me 1. When I divide the 0.7286 and I divide that by 0.3698, I can see that's roughly a 2-to-1 ratio, isn't it? I divided that out and I get a value of 1.97. So now I have to determine, I have to ask myself, is that 1.97 pretty close to a whole number? What would be my whole number it'd be close to? 2, right? So is that pretty close to a whole number? I would say yes, it is. So what I'm going to say here is that my mercury, my empirical formula with this is going to be my Hg is 1 right here, and my Cl is going to be 2, because that's very close to the whole number 2. So my empirical formula is going to be HgCl2. Well, let's go back and look and know and remember what we know about our bonding. And I look at this and I say, okay, mercury's a metal, chlorine's a halogen, a nonmetal. Would it make sense, looking at mercury, it can take a +1 and a +2 charge. So would this make sense to have HgCl2? Absolutely. That would be mercury 2 chloride. Okay? So I go back and look and say, yeah, that does make sense. Here is question number 2. Go ahead and copy this into your notes, and then we will work it. My question states, find the empirical formula of a compound that has a percent composition of 52.94% aluminum and 47.06% oxygen. Once again, I'm going to start out by taking the percentage, 52.94% aluminum, and convert that into grams of aluminum. So I'm going to have these out of 100 total grams. So that means that I'm going to have 47.06 grams of oxygen. I need to flux capacitor this into moles. So I know that 1 mole of aluminum I'm going to have on top because I want the grams to cancel. That is 26.9815 grams of aluminum. I get my grams of aluminum to cancel. So I'm going to have my answer here in moles of aluminum. I grab my calculator and I say, okay, 52.94 divided by 26.9815, and I get a value of 1.97. 962 moles of aluminum. I'm going to do the same thing with my oxygen. I know that 1 mole of oxygen has 15.9994 grams of oxygen. My grams are going to cancel, leaving me with moles of oxygen. So I divide this out, 47.06, and I divide it by 15.9994, and I get a value of 2.941 moles of oxygen. Now, I can tell you, folks, here is the critical point where people miss this particular problem, because they skip the next step and they say, okay, is 1.962 pretty close to a whole number? Well, it is, isn't it? And 2.941 is pretty close to a whole number. But what haven't we done yet? We haven't compared the two of them yet, have we? So we need to get that ratio. So I still need to divide by the lower one. So this is going to give me 1 right here. And when I divide 2.941 by 1.962, it's going to give me a value of 1.498. Now, as I look back at my values, let me come back a little bit here. As I look at my values, now I want to make that comparison. I know I have a whole number right there. Is this 1.498 close to a whole number? It's pretty much right in between 1 and 2, isn't it? So I can't just round that and say, yeah, it's close to 2 or it's close to 1. So I have to now multiply to get that to a whole number. If I have 1.5, what am I going to multiply it by to get to a whole number? 2, right? So 1.5 times 2 is going to give me 3, right? Now, what I did to that one, I've also got to do to this one. So what's 1 times 2? That's going to give me 2. So now my numbers in my boxes up there are going to give me my empirical formula. So my AL is going to be 2, because that's what my box says. My O is going to be 3. Well, once again, there's my empirical formula. Does that make sense? Well, once again, I have a metal and a nonmetal. Aluminum, I know, has a 3+ charge. Oxygen has a 2- charge. So does that make sense to have Al2O3? Absolutely. Absolutely. So that is my aluminum, my empirical formula for aluminum oxide. Now, I want to go back to a point. When we did this right here, this step right here where we had to multiply that by 2 to get the whole number 3. Well, let's look at some things. These things, when we have these, they have a rhyme or a reason to them. So if you get really, really weird numbers, you might want to go back and look. But if I would get a number for my molar ratio of a 1.33, how am I going to get that to a whole number? by multiplying by what? Okay, multiplying by what? Well, isn't a 0.33 a third? Okay, so if I multiply 1.33 by 3, that should give me 4, right? Gives me 3.99. Is that close enough to the whole number 4? Absolutely. So if I would get a number like that, I would multiply it by 3. Okay? What if I would get a 1.75? Okay? A 1.75. Well, let's just start out by saying, okay, what's a 1.75 multiplied by 2? Well, that gives me 3.5, right? Is that what I wanted to do? Is that any closer to the whole number of what I just had? No, what would I have to do with this one then? Multiply it by 2 again, correct? So if I multiply 3.5 by 2, that gives me 7. So basically, what I'm doing is taking 1.75, multiplying it by 4, because that's that 1, 2, that's that second 2, and that gives me 7. So basically what I have to do when I get those points is determine, okay, what number I need to get it to in order to get that whole number. Okay? Make sense? Now, what I would like for you to do, we've got about 2 minutes until this period's over. What I would like for you to do is, I would like for you to work this problem. Once you get this problem worked in your notes, come up to me and show me it. Once you get the okay that you have done this correctly, then you can go on and watch the video notes for molecular formula that are due tomorrow.